right, so for your sample test, for the first part where we do not have our graphing calculator, you do have a scientific, we want to be able to add these two matrices. Now, what has to be true in order for you to add or subtract matrices? Same order, right. So what's the order of this first one? 2 by 2. How about this one? 2 by 2. So I'm going to add a 2 by 2 and a 2 by 2. I can do that. So I'm going to take what's in the first row, first column, that 2, plus what's in the first row, first column, that -1. So 2 plus -1 is +1. That goes in the first row, first column. All right. So first row, second column is 3, plus first row, second column is 1. And so we'll put that 4 in first row, second column. Second row, first column is -1 plus 4. That gives us 3. And then second row, second column, 0 plus 2 is equal to 2. All right. So we add and subtract the exact same way. For number 2, we have a 2 by 2 and a 3 by 2. Can you add a 2 by 2 and a 3 by 2? No, it has to be the exact same order. You can't add or subtract them. So for number 2, we could just say undefined, can't be done, impossible, something like that. All right, number 3, what's this first guy right here? What's its order? 2 by 2. How about this one? 2 by 2. So can I subtract those? Yes. All right, so again, we're going to take what's in the first row, first column, 2, minus what's in the first row, first column, -1. So 2 minus a -1 would be 2 plus 1, or 3. All right, and then 3 minus 1 gives us 2. -1 minus 4 gives us -5. And 0 minus 2 gives us -2. All right, then for number 4, they ask us to multiply. What has to be true in order for you to multiply matrices? Do they have to have the same order? No. Same inside numbers, yes. So for number 4, they gave me a 2 by 2 and a 3 by 2 and asked me to multiply. The inside numbers are not the same, so I can't multiply. So again, I would just say undefined, can't be done, impossible, something like that. All right, then for number 5, we had a 2 by 3 and a 3 by 2. Can I multiply those two? How do I know? Inside numbers are the same, right? So these are the same, so I can multiply. What do the outside numbers tell me? Size of my answer, right, what my answer is going to look like. So I know my answer is going to be a 2 by 2. So I'm going to go ahead over here and draw for myself 2 rows and 2 columns. That's really important because that tells me what to multiply. If I want to know what goes in the first row, first column, I'm going to multiply the first row times the first column. So if I want to know what goes in the first row, first column, I multiply first row times first column. So I'm going to do 2 times -1, 3 times 4, and 1 times 0. All right, so that's what we got right here. 2 times -1, 3 times 4, and 1 times 0. So if I combine those, that gives me my +10. All right, let's try another one of those. What's the name of this position right here? What row, what column? First row, second column. Okay, so to get the answer there, I'm going to multiply first row times second column. So I'm going to do 2 times 1, 3 times 2, and 1 times -2. So that's what we see right here. And so when we combine that, that gives us our +6. All right, what's the name of this position right here? Second row, first column, right. So I'm going to take the second row times the first column. So I'm going to do -1 times -1, 0 times 4, and 2 times 0. So that's what you see right here. And we can add those up to be 1 plus 0 plus 0. So that gives us 1. All right, and then what's the name of this guy right here? Yes, row 2, column 2. So I'm going to take my second row times my second column. So I'm going to do -1 times 1, 0 times 2, and 2 times -2. So that gives us what we've got right here, which is our -5. All right, so that's how we multiply our two matrices. All right, number 6, they ask us to find the inverse of a matrix. And I told you that I would only ask you to find the inverse of a 2 by 2. If I asked you to find something larger, like a 3 by 3 or something like that, it will be on the calculator part. All right, so to find the inverse of a 2 by 2, we have 2 different ways of doing that. I actually liked the formula way. If you like the Gaussian elimination way, that's perfectly fine. You can do it that way if you want to. All right, but I'm going to do it using the formula. So here's our formula for finding the inverse. It's going to be 1 over AD minus BC. And then we're going to shuffle that matrix. So you can see that A and D switch places. B and C stay where they are. They just change signs. So that's a formula that we have to know. Like, there's no other way to do that without knowing the formula unless you want to do the elementary row operations, the Gaussian elimination thing. Okay? So, if I'm looking at this matrix right here, it goes A, B, C, D. All right? So, to do AD minus BC, I'm going to say negative 1 times 6. So that would be negative 6 minus negative 2 times 4. So that would be negative 8. So basically you're doing your main diagonal minus your alternate diagonal. So negative 6 minus a negative 8 gives us a positive 2. So that's where our 1/2 comes from. All right, now we're going to shuffle the matrix. So remember it goes A, B, C, D. A and D switch places. So you can see that the negative 1 and the 6 swapped places. B and C stay where they are. They just change to the opposite sign. So negative 2 changed to positive 2 and positive 4 changed to negative 4. So that's where we got that shuffled matrix, just following that formula. So now we're going to do scalar multiplication. 1/2 of 6 is 3. 1/2 of 2 is 1. 1/2 of negative 4 is negative 2. And 1/2 of negative 1 is negative 1/2. And that would be our inverse. All right. Now there is one other thing that we need to be able to do on the non-calculator page, and that is number 8, solving the system by elimination. So let's look at that for just a second, and then we can kind of switch to graphing calculator mode. Okay. So for number 8, when they ask me to solve by elimination, that's where we're trying to get the coefficients of one of our variables to be opposites of each other so that they'll eliminate. So I'm going to multiply this first equation right here by a positive 3 and multiply my second equation by a positive 2. That way I'll end up with a positive 6x and a negative 6x that'll eliminate. They'll drop each other out, okay? So I'm going to multiply this whole first thing right here by 3. So that would be 6x plus 9y is equal to negative 24. And then I'm going to multiply this whole second one by 2. So that'd be negative 6x minus 10y is equal to 28. So our 6x is eliminated just like we wanted them to. A positive 9y and a negative 10y is a negative 1y. And then negative 24 and positive 28 is going to give us positive 4. So now how do I get y by itself? Divide by negative 1. So y would be negative 4. Now once you know y, how do you find x? Plug it back in. It does not matter which one I plug it into. I could plug it into this one, this one, this one, this one. Makes no difference. Pick whatever looks easiest to you. I picked the first one. And remember, this was y equals negative 4. So I'm putting the negative 4 in for y. So that would be 2x minus 12 equals negative 8. Add 12 to both sides. I'll get 2x equals 4. Divide both sides by 2. And I'll get x is equal to 2. So I can write that as the ordered pair 2, negative 4. Now the other thing that we need to be able to do without our calculator is tell what kind of lines are these and what kind of system is this, okay? So when you get exactly one answer, like we just got right here, 2, negative 4, if you get one solution, how many intersections do you have? 1, because solution equals intersection, right? So if you have one intersection, is that parallel lines, intersecting lines, or overlapping lines? Intersecting. Intersecting lines, are they consistent or inconsistent? Consistent because they have an answer. Are they dependent or independent? Independent because there is only one answer. One can stand entirely by itself, independent of everything else. Okay, but what if on that problem, instead of getting an answer like that, what if I had gotten an answer like 0 equals 0? What does 0 equals 0 mean? It means that it's infinitely many solutions, right? There's not just one answer that'll work. There's a ton of different answers that'll work. So what do I put in my answer blank? 0 equals 0 or infinitely many solutions? Infinitely many solutions. It said solve, right? Okay, so if you have infinitely many solutions, how many intersections is that? Infinitely many, right? So what has infinitely many intersections? Parallel, overlapping, or intersecting? Overlapping, yes. So those would be overlapping lines. And they, because they have a solution, are consistent. And because they have lots of solutions that all depend on each other, it's consistent dependent. All right, what if you had gotten an answer like 0 equals 4? What does that mean? No solution. There's nothing you can put in there that's going to work. So if you have no solution, how many intersections do you have? None. So what kind of lines are those? Parallel. And what kind of system is that? Yes. Okay, so that's what I need to know on that first page, because it could be any one of those things. Now you're going to have your graphing calculator for the rest of it. So I've worked each of these problems out by hand and on the calculator so that you can do it whichever way you prefer. Okay, so let's start with number 7. So for number 7, it says solve the system by graphing. Now, if you want to graph this by hand, you're welcome to. Like I took 3x plus 6y is equal to 0. You could make an xy chart for that. You could get y by itself and put it in slope-intercept form to graph it by hand. Same thing over here with 4x minus 2y equals 10. Make an xy chart, find the x and the y intercept, put it in slope-intercept form, whatever you like best if you want to do that by hand. But you can just throw it in your calculator, right? So to put it in my calculator, I have to put it in the y equals form. I would still have to do this work right here by hand to get y by itself. Do this work right here by hand to get y by itself. But once I do that, I can just put that into y1 and y2 and hit graph, and it will graph it for me. Now, on your test, there's going to be a place for you to graph it. You could just copy that off onto your paper. It doesn't have to be perfect as long as I can tell you knew what you were talking about. Now, I'm going to have an answer blank. What goes in my answer blank? Where's my solution? At the intersection, right. So I need to find that point of intersection. If you can look at your graph and see, hey, that's a positive 2, negative 1, then that's fine. If you look at it and you're not sure if that's the point of intersection, remember you do have an intersect button on your calculator. So once you have both of those in graphed, all you have to do is second trace to get to this menu, and you could go down to intersect. It's going to ask you, what do you want me to use for your first curve? And we hit enter. What do you want me to use for your second curve? And we hit enter. And then it's going to ask me for a guess. You can just go close to that point of intersection for your guess and hit enter. And then it will spit out for you, your point of intersection is 2, negative 1. So again, you can do it by hand and get your point of intersection, or you can do it on your calculator, whichever you like better, because you're on the calculator page.